In this video we deal with the motion of particles due to the temperature. Such a particle motion in gases or liquids is also called Brownian motion. So let's get started. If a substance is heated and thus its temperature is increased more and more, it is observed that the particles contained therein move faster and faster. Be it the oscillation of the particles around a fixed position in solids, or the relatively free movement of the particles in gases or liquids. The temperature of a substance can therefore be regarded as a measure of the velocity of the particles it contains. With a higher temperature and thus higher particle velocity, the kinetic energy of the particles also increases. Therefore, the following statement applies: the higher the temperature of a substance, the greater the kinetic energy of the particles. Note that particle motion in the context of temperature is always a random motion. Thus, the temperature of a substance will not increase because it is moving at high speed and the individual particles are faster overall. This is because it is no longer a random movement of the individual particles. Rather, the random motion of the particles is superimposed by a directed movement. Such directed motions have no influence on the random movement of the particles inside the substance and thus on the temperature. We can therefore make the statement of the temperature a little more precise. Temperature is a measure of the disordered kinetic energy of a particle in a substance. Rising temperature is generally associated with a corresponding increase in the space occupied by the particles due to the increase in velocity. This means that substances generally expand when the temperature increases. Conversely, this means that a substance generally contracts when cooled. The resulting decrease in volume is associated with a corresponding increase in density. The phenomenon that substances generally expand when heated is also known as thermal expansion. This effect is used, for example, in liquid in-glass thermometers to measure temperatures. Note that temperature is ultimately a macroscopic quantity. This means that it can be measured macroscopically, while particle velocity can only be observed on a microscopic scale. Nevertheless, both quantities are connected. The table summarizes the properties of the particles in the different states of matter. Note that with some substances such as water, a so-called negative thermal expansion occurs within a certain temperature range, which leads to an increase in volume despite falling temperature. Since each substance can be assigned a certain temperature, the molecules contained in it are obviously in constant motion. This random thermal motion of the particles due to the temperature is also called Brownian motion. Brownian motion can be observed indirectly if an open ink glass is carefully placed in water. Even if the water and the ink are macroscopically completely at rest, one will notice after some time a mixing of the water with the ink. The reason for this is the Brownian motion of the particles, which causes the water molecules and ink molecules to mix due to permanent collisions. Differences in concentration are gradually balanced out. Such mixing of different substances due to the Brownian motion is also called diffusion. The higher the temperature, the faster the diffusion will be, because the stronger the molecule movement and thus the mixing. In a similar way as the mixing of gases or liquids can be attributed to Brownian motion, a movement of particles can also be observed in solids. Although the particles in solids are usually bound to a certain location by electrostatic forces, they oscillate more or less strongly around their rest position, depending on the temperature. Due to these oscillations, foreign particles can move through the atomic structure. The particles are pushed through the atomic structure, so to speak. As the temperature increases, the lattice oscillations increase and the distances between the oscillating particles increase too. This allows diffusing particles to move better through the lattice structure. It is also true that the higher the temperature, the faster the diffusion process. We hope you enjoyed the video and found it helpful. Thanks for watching.